So I think we're going to get started. Welcome back. Good to see you all. I hope you all slept well, had some good breakfast. We're going to start day 2. And also welcome to folks in the Zoom room. So hopefully that's rolling as well. So just a brief overview. We talked about this a little bit yesterday, but our goals for this workshop were born out of the feedback that we got from all of you from last year's workshop and the themes that we learned from that. And so those were, 1, fostering bidirectional communication between Crescent scientists and broader community and partners, but then 2, exploring the emergent themes of the workshop. So those were science communication, which we covered yesterday in the session that Ellen Peters and Maxwell Eli led. And then today we're going to focus on emergency preparedness and response planning, data access and availability, and resource limitations. And so we've got 3 sessions for that today. The first one is going to be about earthquake scenarios, and this is something that was actually kind of cool yesterday in the Cascadia Connections exercise. The table that I was in honed in on this almost immediately, so it definitely sounds like this is something that's of interest to folks. So we're going to have some presentations on that and then a breakout for a chance for everybody to interact. Then we have a session about building a Cascadia data dashboard, which is about data access and availability and sort of compiling that in one place. And then we'll have the last session is in collaboration with NAGT, the National Association for Geoscience Teachers. So they're having their annual workshop right now. And that session is going to be about addressing skill gaps, training needs, and geoscience education opportunities. Then we're going to have lunch, and there are the optional field trips. So we'll check in with you about that in the afternoon if you signed up for one of those. A few housekeeping things. First, for the morning in the sessions, we'd love to have as full tables as possible. So if you're at a table that only has a few people, if the few of you would be willing to move to another table so that way we can have some full discussions. And you don't have to do it right away. You can do it before our breakout. But otherwise, for the sessions, there's no assigned facilitator. So if at your table, you could assign somebody to take notes. And the notes are available at this short URL up here for each session. So this is all the note-taking documents for all the sessions. And then for each one, we'll have the specific URL up there. You can also find some paper versions on your table if that's easier for you. And then when you're done with it, save the file with your table number on it and email it to cascadiaquakes@uoregon.edu. And this is really helpful because this will help us figure out where we're going for the next year and what we do with our mission. And then also there's a code of conduct. So you can find that at the QR code up here, and you can also find it in the back of the room. So we ask that everybody please adhere to those guidelines on there. And if anybody or anything is making you feel uncomfortable, please come find one of the Crescent staff, myself, Andy Clifford, Jill Elizabeth, who's in the back, or Amanda Erickson, who's also in the back right over there. You could raise your hand. We've got coffee out all day. Restrooms are in the back hallway over there. They're gender neutral bathrooms. And then in terms of emergencies, fire exits are, I guess there's a door right here. And you can also go down the stairs the way that you came in. There are a handful of exits that way. And if there's an earthquake, drop cover and hold on. The last thing before we start is that if you have questions that aren't answered in the session that you'd like answered of the speakers, you can send them on this form over here. So there's a QR code here. It's also in your handouts if you have a question and we don't have this up. And then what we'll try and do is ask those of the speakers, and with their permission, post them on the website later. So if there isn't time, you can still get a question answered. So that's what we've got for now. And we're going to move into the first scenario, or the first session, which is about scenario needs for Cascadia. So lastly, as we start, we'd like to acknowledge the National Science Foundation and Federal Funds for Subduction Zone Science Research, which has made this possible. And I think it's also really in line with the session, which is about making the connections between knowledge production and societal relevance. So how can we translate the things that we're doing in the science space into scenarios, and then how that impacts the work that everybody else here, or all of you, are doing. This is going to be facilitated by Tiegan Hobbs. Tiegan is a seismic risk scientist for the Geological Survey of Canada, as well as faculty at the University of British Columbia. It's my pleasure to introduce her.
Good morning, everyone. It's so nice to see everyone here for a second day of this conference, and what a treat to get to work our way through this session. So thanks for inviting me. Yeah, we're gonna go ahead. I'm gonna give a really high-level overview of a little bit of what are scenarios, how do we use them, coming from my perspective as a physical scientist working in science and engineering. And then we're going to hear from some other folks, and then we're going to have hopefully a really productive discussion. So earthquake scenarios, first of all, what are they? They're a deterministic characterization of an earthquake that may include impacts. And that is a fancy way of saying sometimes when we want to think about what will the impacts be of earthquakes, we can think about, well, what will the impact be of many different earthquakes? And we usually call that probabilistic. Or we can think of just one individual scenario, one earthquake, what will be the impact of that, which we call deterministic. And you can kind of think of it like if we wanted to compare it to car crashes, then if you wanted to look at what are the statistics of car accidents on a particular highway, that's a probabilistic look. If you wanted to look at like one crash test dummy simulation, that's an earthquake scenario. The next question, who cares about these? And I actually think almost everyone, probably everyone in this room. So it's almost a little silly of me to describe what these are. But in my work, we produce a lot of scenarios and we work with people like emergency managers, health emergency managers, communication specialists, policy analysts, civil servants, financial planners, folks in industry, including finance or insurance or engineering. We work directly with first responders, community groups, and many others. Finally, why do we care about scenarios? And I was trying to think of how to describe this in one sentence, and I came up with that we use them for thought experiments about how we will respond to events like these and to test our capacity versus the demand that we might have. And that is quite vague, and it's because I think that there are so many uses that we can have for earthquake scenarios, depending on who's asking for them. So here's just a few examples of how that might go on this spectrum I've set up from thought experiment to real world testing. And so sometimes we've developed scenarios that are just going to be used for communication or publication. So if you're doing some sort of educational campaign, then you can use a scenario to, for example, write out a narrative. There was one really great example in North Vancouver in Canada where they wrote out a series of vignettes of different people experiencing an earthquake and where they were when the shaking happened, the things that they had to do during shaking and immediately after. And it was easy for people to put themselves in the shoes of one of those characters who was most like them and to really think about like, yeah, what's that first 12 hours going to look like? Like, how am I going to find my family? And like, if the bridges are down, how am I getting there? We can also use scenarios for policy and planning. So for example, we might look at a scenario to say, what's the, and I sort of hate this term, the worst case scenario, because of course that's a super subjective term. But you might want to say, what's the worst thing I could reasonably expect? And then to say, do I have sufficient policy to be able to respond to that event? Or if I'm an emergency manager, do I have sufficient protocol in place that we're going to be able to respond to that level of event? We can also, of course, use scenarios for tabletop exercises. That's where we might all be sitting in a room like this, and I would come up and describe a scenario to you, and then you folks would all work together to think about how would we respond to an event like that. And like you're sort of looking at what you have on the books and sort of talking to each other to see how might it play out. And then, of course, we have full-scale exercises, which is where you're not just all sitting in a room together. You're in your emergency operations centers, you've got your vests on, there's first responders out doing drills in a field somewhere, the helicopters might be flying. Like you're really trying to put all the pieces together, get everybody really physically involved. And you can learn a lot from these, of course. You know, they'll do a big hot wash and a debrief afterward and really see, okay, how did things stand up? I think one of the really interesting things that we can hopefully be thinking about and discussing today, or something I'm really interested in, is what are the needs of users? As a physical scientist, when I'm creating a scenario, I really try to spend quite a bit of time establishing what the needs are of whoever's asked me for the scenario before I start working on it for them. And so from my perspective, some of the needs, I think, are for these scenarios to be realistic and credible. That's maybe the top reason that I get called in as a geophysicist, is that they need to know that this is something realistic, that also it needs to speak to any discussion topics or themes. So if the person who's asking for a scenario, let's say if they're in finance, then we need to make sure that we have information about the economic consequence of that event, and that that's sort of what we're focusing the scenario around. I did one for a First Nations Health Authority in Canada, and so then we wanted to think a little bit more about what would the human impact be, and what would it be particularly in kind of rural or remote communities that might become isolated. Um, the results need to be presented in a digestible format, and what a digestible format is radically different for different groups. Some folks want a spreadsheet with numbers in it and like a quick description of the headers, and then they are off to the races. Other groups, it might be much more of a narrative. It might be a presentation. Maybe they want me to come and like really, kind of talk through what it would all be like. And these are all totally valid. And again, I think it comes down to understanding who's asking for the scenario and what do they need to make their activity or their planned work successful. It really needs involvement and engagement from all the relevant groups. And I know that's like the worst part to hear because we'd love if there was just like a great way to always know how to do a right scenario or how to ask for the right scenario from a scientist. But I think it's much more involved than that. It's really nuanced, and like I'll have like 40 emails back and forth about what does the term credible mean to you, or like what does worst case mean. That's a very long email thread always, every time. And also there needs to be a paper trail. I think that's a really tough one, is that sometimes when we're building scenarios, we build them for, some exercise, and then it's used for the exercise, but where does it live after that? And so we end up kind of recreating the same scenario a million times. And I think that creates quite a bit of confusion, because folks don't know which scenario they can turn to use again in the future. And they might start to say, well, I saw a 6.8 that was used, and then now you're telling me it's a 7. And for some users, that is like intolerable level of change, and that's totally valid. And I think as scientists, we can think about having a paper trail so people can point back to that exact earthquake. Really quickly, some of the challenges as well. I think knowing what level that people want to plan to in terms of how severe the event would be is a conversation that I spend a lot of time having. Like a 1 in 500 year event is, we can like know exactly what that is if either determining it by 1 in 500 shaking or 1 in 500 loss. But usually it's not defined that way between myself and the stakeholder. It's defined with more qualitative terms like worst case, or like pretty bad, or like would test the system. And of course, like we really have to like dig into what would test the system. I think also getting all the agencies together is a big struggle. One of the big ones that we talked about yesterday too is including secondary perils and multiple hazards in our scenarios. I think that's something that we can do ad hoc. Sometimes in a really hand wavy way, where someone will ask me like, what would be the impact of fire following the earthquake? And I'm like, well, I can't model that for you, unfortunately, but I can find some studies and then find some piece of that study I can apply and give you a rough number. So it's useful, but I think that's something I'd love to see our scientific community working towards, is like full integration of how to include secondary perils, especially because I think in the insurance and finance industry, they're already doing that in the like CAT modeling firms. And so if we want our science to be useful to decision makers, we need to at least sort of, I think, meet that. As I mentioned, we also did some work with the First Nations Health Authority. So that's Indigenous groups and the health authority that manages them. So they wanted to better understand how a scenario might impact their communities, even if they're a little bit farther away from the coast. And so for this, we were looking at the hospital demand from a scenario, and then breaking it down by municipality and splitting that into whether it would be standard hospital care or ICU care. And so we're able to let them know, like, yeah, what's your hospital capacity? Because here's what the demand would be. And then lastly, we've been working with the city of Vancouver, starting to think about the possibility of maybe a retrofit policy, which currently in Canada, there's no standing retrofit policy anywhere, no mandatory retrofit policy. And so we were looking at, this is a shallow magnitude 7.2 scenario in the Strait of Georgia, so the water just off Vancouver. What would be the number of daytime fatalities from different building types? And then you can, don't worry too much about the colors, but they're showing different occupancy types and different design levels or code levels from the different buildings. And so we were able to say, this is what it looks like now. If we were to retrofit, this is what it would look like instead. And so it helps us to be able to identify exactly which building types would give the best return on investment or bang for your buck if you were to retrofit them. So with that, I'm going to wrap up. Awesome. Okay. And then our last speaker is going to be Albert Kottke, a principal at PG&E who works in ground motion modeling and seismic risk.
Good morning. Good morning, everyone. Okay, today I'm going to talk about the use of earthquake scenarios. Perfect. For a risk evaluation. Before we get into that, I want to talk about risk attitude. So risk is how we measure the impact of earthquakes to our infrastructure. And when we think about that impact, it's not necessarily a linear relationship. Not all losses are the same, and it depends on your risk attitude. Today, I'm going to be talking about a risk-adverse attitude, and that means as the consequence increases, the risk score or the perception of that increases. Now, there's also, you could be risk neutral or you could be risk seeking, and that's going to change that curve there. But being the fact that if we're risk adverse, that means big events are going to be felt more impactful than if you had small events that were repeated. At PG&E, we do this using a multi-attribute risk score that includes both safety, financial, and reliability. And this risk adverse scaling changes how earthquakes are evaluated. So today I'm going to be talking about the San Francisco Bay Area, which is not in Cascadia, but I'm doing that because it's a collection of assets that we own and we think about in this perspective. Besides San Francisco, we own a lot of assets in the northern part of California. And when I think about scenarios, I think about the range of impact to all those assets simultaneously from a large Cascadia event. Here we selected San Francisco because it's such a dense area with a lot of assets. We've got electric transmission lines, gas transmission lines, substations, and corporate real estate buildings. So when we develop scenarios, we just don't develop one scenario, we develop a suite of scenarios. And to do that, first we need to start by identifying the seismic hazard in that area, and we'll do that over a grid of points in the area of interest. We then select seismic sources within that area that are going to provide that are hazard significant. So for the Bay Area, that might be the San Andreas Fault, the Hayward Fault, maybe the Calaveras Fault, and some other ones. If we're here and we're talking about Cascadia, then we can talk about Cascadia, but maybe also include crustal sources as well. In this work, from those sets of scenarios, we created a suite of around 300, developed a suite of 300 scenarios, with each scenario being a map of ground shaking and associated rate of occurrence. We did this using basically a Bayesian process, and it captures both the spatial and intensity measure correlation. So we can have ground shaking at different spectral accelerations, but also spatially, and it's capturing the variation in behavior across the map. And so you can see the figures on the right. The top row is showing the ground motion at the site. The middle row is showing the site amplification, and the bottom row is showing sort of a reference condition of the S30 of 760. And we have pockets of strong shaking and weak shaking. And the fact that we have that spatial variation in ground motion is very important. We can then take these maps and we can combine them with secondary hazards like liquefaction and landslides. And we can also look at how assets are performing. Because we have a suite of maps, these suite of maps capture the hazard at any point. We reconstruct the hazard over a fixed return period interval. And we can then look at the impact of a specific building, but also a collection of buildings. So on the left, I'm showing two different plots. We have the red line is a hazard curve that we're trying to fit. The blue points are samples of our scenario maps at two different locations, the top bottom row. And what we did is we took our scenario maps and we applied, we would typically do with a risk evaluation, we would take a hazard curve, we would look at the performance of a building, and we would add up all of the loss as a function of ground motion, and we would add that up. And we would do that for all of our corporate real estate within our sort of study region. If we do that and we repeat that using just the hazard alone, the scenarios, or the hazard implied by the scenarios, So the green and blue bars represent just like location-specific hazard estimates. And we can see that they're similar because we're recovering the hazard in our scenarios. The orange bars represent the risk score estimated using those scenarios. And what we see is the risk score is much higher when we apply a scenario-based evaluation of the risk. And that's because we are risk adverse. And what we see is that when we have the earthquake scenario effects are more pronounced for building clusters, because when you have one building damage, you typically are going to see other buildings in the same location that are equally damaged. And so this is from the perspective of our building inventory and our potential for when we have assets, they tend to be close together. And so if we have an asset that's damaged, we're actually going to have multiple assets damaged in that same location. And that's going to drive the impact of that event to be higher. So this is for a risk adverse perception. If we were risk neutral, it wouldn't matter because there's no scaling. But if we think of and we apply this to sort of the greater population, then if we are risk averse, then that scaling is going to be even higher. And the study has only looked at buildings. We're going to add in other assets in the future. But if we think about in terms of communities, there might be some scenarios where some communities be really heavily impacted, and we could see a lot of devastation. In other scenarios, it might be that the ground motion just isn't high in that location. And so we really need to be able to sample to understand, well, what are the ranges and potential outcomes that we could see? So the advantages of the scenarios is each scenario is associated with a rate of occurrence. We actually have that information, and it's consistent with the hazard. It's consistent with our state of understanding of likelihood of ground shaking. And changes in the hazard can be accommodated through new maps. We can always generate new maps to be consistent with our sort of understanding of rate and ground motion. We can use a limited number of maps. In this case, we're working with around 280 maps, which seems like a lot, but as you reduce that down, you need to see sort of like more sort of skewed behaviors in ground motion. And that depends on sort of the return period of interest and spatial area as well. But 280 samples is not too bad. We're not talking about thousands or millions. And so it's still a reasonable number, I think. And the value of this process is we're capturing both realistic spatial and intensity measure correlations. If you would have done that from a median ground motion, it would be very smooth and not capture the fact that you have pockets of damage that's correlated. So an application to Cascadia, we can think of, so this was just applied to one single metropolitan area. In Cascadia, it's going to impact a much larger area, but again, we're going to see pockets of strong shaking and weak shaking. If the community is risk adverse, then that impact of the event is going to be much greater than the impact of just one asset. And so we're going to see actually the impact to Cascadia larger than we would expect. So to quantify that impact, we need to consider spatial correlation in the ground motion that we're developing. We need models that are going to be capturing that spatial correlation. And we also need to understand our hazard and how that they're fitting together. And finally, the Bayesian scenario maps method that we've been working on can combine these information and can be used to extend the information to include simulations to capture that spatial correlation in a suite of scenarios. And with that, I'd like to thank you, and now we can have our engaged discussion.
Thanks so much, Albert. That was really interesting. So we've got a moment to take a couple of questions. Does anyone, over here maybe?
Looking at Cascadia region, the ground motion estimates for different types of ruptures radically differ. Particularly when you look in the I-5 corridor. And it seems that emergency managers have kind of adopted the worst of the worst of the worst case scenario, destroying all the bridges up and down, the infrastructure, the utilities. And to me, that seems to kind of put a real negative bend that this is not survivable, so why even try? whereas really it probably will be moderate damage in the I-5 corridor, and it's going to be pockets of severe damage, but not everywhere. So how does that factor in when you were looking at, what scenario to apply where, when you have such a wide variety of ground motion potentials?
Yeah, maybe I'll start off, and so I'll caveat that I don't work in Washington, Oregon, so I'm not actually right in that I-5 corridor. The sense I've gotten is that the public is definitely thinking about these like really cataclysmic versions, and all the bridges are out, everything west of I-5 is toast kind of situation. I don't actually experience a lot of emergency managers wanting to talk about that level of destruction. In my experience, I found that emergency managers are maybe often either saying like, give me something that's just strong enough that it will be difficult, but we can manage it. Because I think for the exercises that they're often doing, they don't want to leave people with that feeling of like fatalism or nihilism, that it's all going to be like dust, so who cares? Or sometimes they're saying like, yeah, give me, like, show me the numbers of what you think a realistic very bad situation would be. And I find that's more for like the thought experiment, not so much for the tabletop exercises, because in my experience, the emergency managers, they're very practical, they have so much on their plate. So they want something that they can exercise that's going to give them a chance to like stretch their legs but not break their legs. If that's an appropriate way to say that.
I guess I would follow up with, I think it's hard because you want to, like you said, stretch and think what can we prepare for? But it's also really hard because we don't expect the mean ground motion everywhere. And so if we're going to bring in, and sort of the current approach is you bring that entire surface up, like you're going to be pushing the whole region higher than you expect or something like that. And so I think when you really get to try and quantify where we're going to be, the outcome of a suite of scenarios, you end up having a confidence interval of like where you expect, how many buildings you think you're going to be out. And I think it helps understand sort of the range of potentials and do a better job. But what it means is now you've got 300 scenarios you need to work through and understand, well, what are the consequences of each of these? And then you can start running tabletops of, okay, I'm going to randomly draw this event and look at it and see what their potential future could be. But I think it's a tough question because you want to convey the importance of it, but then also at the same time understand that there are a range of potential scenarios and outcomes that are possible.
Okay, so yeah, thanks again to the other speakers. Now we're going to move on to some breakout groups. So these are the discussion questions here. I won't read them out because y'all can read them. But we're going to have about 20 minutes for the discussions. You're going to stay at your table, or if your table is sparsely populated, please feel empowered to move to a different table. We're going to start by doing kind of the pair small group. So maybe turn to the person next to you, have a think about all the questions you want, or maybe just for a few minutes, pick one or two to talk about. And then you can go out to your larger table and kind of all discuss together. As already mentioned by Valerie, you can pick one person at your table to be a note taker, either using the URL up in the top right of the slide or using the sheets that are out on your table. And then after about 20 minutes, we're gonna do a popcorn share out. So we'll maybe, if there's a few tables who had a really interesting or salient finding, then we'd love to hear about it as a big group. So if there are no questions, maybe we'll start it off.
Okay, so I think we're gonna do share outs now. Hopefully you've all had a moment to wrap up and take some notes. And I know, I'm sorry, it seems like there's really great discussion going on and I don't want to cut it short. Thanks. Okay, good. Thanks. Oh yeah, do you want to bring the mic around? Yeah, cool. Yeah, so I think we've only got about 5-ish minutes before we have to move on to the next discussion session, but I guess, is there anybody here who would like to share some of the things that they talked about? Maybe take a couple? Yeah, maybe. Jay? Push the bottom one.
Hello.
Hi, I'm Jay Wilson with Clackamas County, Oregon. I just wanted to put this out there as kind of the elephant in the room with scenario development. From, at least from my perspective, is almost the answer to every one of these questions right off the bat is it depends. And it's the challenge I think that we have with such a big multi-state regional area compared to, say, the Bay Area as an area that you're working in is anytime we've had to develop scenarios for immediate response or for long-term recovery planning, you have to work with so many artificialities outside of a given region, like the Portland metro area. If you're thinking about recovery coming in, knowing that you're competing with Seattle, there's all of these kind of what ifs that you have to put in. And so at some point, the artificiality becomes really burdensome. And so the nature of working in Cascadia is, I just think, is always going to be a challenge in the way you're framing the scenarios for the end users and the kinds of assumptions that you have to make that happen in such a big regional area of coverage. And so off the bat for all of you, dialing it back in and having moving targets is just going to be the nature of the beast that way. And so right off the bat, I just wanted to tag that going forward.
I definitely appreciate that. Thank you. Yeah, and I don't know if there's either other share outs for your tables, or if you just want to sort of have discussion, like follow the threads of the discussion, that's okay. We've got about 5 minutes to do that. Looks like Bob.
We had a really great conversation at our table, but I just want to mention, I know there's a few of us in this room, several of us in this room, that are involved in the Shakler earthquake early warning system. And we're constantly in the process of recruiting new people to try out new implementations and to get them to do things. And they're always asking us questions like, what should we plan for? What should we do? So really one thing that I proposed, and I'm sure that my colleagues would have pretty much the same idea, is a way to marry scenarios with Shake Alert so that we could give those who are actually going to be delivering Shake Alert powered products and services the tools to be able to make decisions about what they do, what they don't do. Also, it could be just used as scenarios could be used as a recruiting tool at all. I mean, as a basic thing to get them to even get interested in Shake Alert. So thanks.
Ellie?
Thank you. I don't work a lot with scenarios, so this could be something already included, but my perception is scenarios often involve a lot of the scientific information as well as the emergency response information. As someone who works more in communication, outreach, I'd love to see more of a focus on media, PIO, who speaks, who's the authoritative voice, and how, when we're working across state lines, national lines in some cases, how to coordinate around sharing information.
Yeah, Albert.
We talked about this a little bit, but the difference between scenarios where you're thinking about sort of an event, but then exercises where you're actually carrying out and following through, and whether that's a tabletop or actually like a full scale exercise or something like that. I think there's just so much to be learned when you actually have to do it. And I think from emergency management, like there's a lot of lessons learned there, but from scientists, I think we can also be thinking about how the science will be responding to. And so I think thinking about scenarios, but then also exercises we're actually like practicing what we do.
Cool.
I love it. I'm getting my steps in.
This is Liz, right?
This is Liz, yeah.
Okay.
We also talked about the need to translate scenarios into impacts and to think about ways to convey those impacts in terms of experiences. And, you know, we sort of rolled around different ideas about that, but I think Dara brought this up yesterday, that the need to see something happen, you know, maybe something bad sometimes, but so that you can put yourself in that experience. So scenarios translated into impacts, translated into some vicarious experience.
It's cool. Oh.
I keep harping on this one tabletop I went to a few months ago. Jay was there. 7.0 Cascadia, and we were having a tabletop for how it would impact Portland. And a 7.0 Cascadia, from my understanding, would not be significant enough for us to even, have that conversation around. But it was apparent to me that almost no one in the room understood that. So for me, scenarios are an opportunity to educate responders, and that trickles down to the volunteers doing the outreach, right? Like, so I think that our responders need really varied and robust scenarios that can show them that a partial rip might look like this and a full rip might look like this, and during the winter it might look like this versus in the summer, et cetera. I think it's a really great learning opportunity for them.
I think, CRESCENT might be able to put together a repository for scenarios that others could use as a starting point so that we don't have to fight the same misinformation battles on every one we go to.
Love the
Noted.
snaps for that.
Yeah.
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 Right. Anyone else? Okay.
Yeah, I think we probably have to move on. I think something that Andy and I were just talking about during the session is that it seems like there's so many pieces to this and so many different parties that maybe would be interested. And I don't think it's something that we have had plans for, but it's something that could probably be a full day in and of itself to talk about all this. And anyway, so I think if this is something that you all think is interesting and useful, or useful to pursue, we'd love to hear things related to all this in the feedback and figure out if collaboratively, is there a way we can all make it happen, seek funding, what would that look like, and is there anything that you'd like to see us do to support that? Okay, so I think we'll move on to the next session, which is building a Cascadia dashboard. And this is also came out of last year's workshop, which is there's so much data, both for science to enable it to happen, that comes from the science, that is used in an applied sense. And what do we do with all of it? It's all hosted in different places. And so that's essentially what this session's about. And so Michael Olsen from Oregon State University is going to lead us through this one. Mike is a CH2M Hill Professor of Geomatics at Oregon State University in the School of Civil and Construction Engineering. And he is also on the Partnerships and Applications Committee, and we're really grateful for his work.
All right, thanks, Valerie. And then the conversation at the end of that last session just segued perfectly into this session and talking about how do we get all these products. Yesterday, there were a lot of great presentations by the different groups within CRESCENT about all the different products and all the databases that they're compiling. And so this session, we want to kind of get you thinking about what are ways that we can get this information out here in ways that it's usable, that people can digest. On one hand, we always like to say we want the one-stop shop, but then when you see the one-stop shop, you can't find anything on it because there's so many things packed into there, right? So is there a way we can make things concentrated but still easy to find and have kind of maybe specific platforms or applications that help out with it? So we're very fortunate in this session. We've got two really excellent speakers in here, and then a third person you're kind of stuck with at the end. But our first speaker is going to be Lydia Staish from the USGS, who does a lot of work in geology and geophysics of active crustal faults, and she's going to talk about some of the work and databases that they're compiling, as well as some of her thoughts for what could go into this database and this infrastructure. And then she'll be followed by Megan Anderson, who is working for Washington Natural Resources and basically develops a lot of places, clearinghouses to help get data out and help people with that.
Awesome. Okay, great. So I am here representing one of the state surveys involved with CRESCENT. And I'm going to give you a little vignette of an existing database structure that's here and available, and should be part of the considerations in developing a Cascadia data dashboard. I want to tell you what it is and why we have it, and then think about ways in which it could interact better with CRESCENT and this awesome resource of the community of people in this room. These are my perspectives as an earthquake scientist at WGS. You've talked to our landslides people, our data managers. They might have very different perspectives. So if you have interest in those areas, I encourage you to reach out to us and talk to us about those specific areas. So I'm going to talk initially about what's in our database. If you go to the Washington Geological Survey website and you look for information on the Geological Information Portal, you'll see this rainbow flag Washington, and you click on that and it comes to a web viewer. So all of our information's in this nice web viewer. You can zoom in, you can turn on layers, and it's set up really well to view data, but you can also then download the data. And when you first pull it up, you have this nice map of the geology of Washington, but I'm highlighting here, there are many, many different layers of data and products that are relevant to the sorts of things that the Crescent community is trying to do. And so I'm just highlighting them there, all the different ones. And I'm going to talk about and show a few of them so you can kind of get familiar with the database. First of all, for data, we have quite a bit of data. We have borehole, shallow data up at the top, and then oil and gas wells that go deeper. We have geophysical and geologic logs. We have our landslides group is very active in mapping. So we have landslide information and many different information on many different types of landslides. We have earthquake information, including active fault map, quaternary structures, VS30, so shallow velocities. We do have earthquakes on there, but I would say that other sources like USGS and PNSN probably have more updated information. We don't really deal in that kind of data as much because we kind of leave it to them. They have great resources. And then we also have a geophysics database. So we have gravity data, magnetic data, seismic data, shallow seismic, GPR, and electrical. And so we have a repository built for a bunch of different geophysical data for Washington. In addition, we also have a lot of products. So we have landslide susceptibility. We have tsunami information, like Daniel talked about yesterday, evacuation maps and routes, hazard zones, scenario arrival times. We do have ground response information like liquefaction susceptibility, and I'm really hoping that I can reach out to Brett Maurer soon and get some better data in there. And I kind of want to pause and say, we have these products, but we're in a constant state of updating them. And I can say our liquefaction map is horribly out of date. And so, you know, I look at this community and say, hey, wouldn't it be great if we could take what's happening here and actually host it on our site? In addition, we were talking about, wouldn't it be great if we had a scenario repository? Hey, guess what? We have one. But it's dated and we're in the process of updating it. So for instance, a great way to interact is this morning, I was gathering all sorts of information on how we should update those scenarios and make them more useful for people like you in this room. And so that's great. We have MMI maps in there and then also has this information. So let's kind of get a little bit more introspective. You know what it is and what's on there. So why do we have this portal? And all the text, please don't read it. It's just to show that what I'm saying is legit. So number one, yeah, it's the law that we find, preserve, and serve geological data to the public. So the law says we have to do this in Washington. And so we have to. I don't care what you guys do in Crescent. I have to do this, right? But I care because I think we could make it better working together, right? The next thing is that it's the law that we assess geologic hazards. So we have to have these products for the citizens of Washington. And then we also at WGS have a very strong ethic to make this info easy to find, which is why we have this portal and try to make the documentation consistently better and keep serving it to the public. We also have an ethic to make it look pretty. And this map back here is a nice example. And one of the reasons is that then it makes it more accessible for the public and kind of brings them in and gets them involved with the data set. And so we also have that ethic in addition to the laws. Okay, so why are these laws and ethics so great for us here at Crescent? Number one, it's funded. It's the law. Our state funds it through direct funding to us. Number two, it's sustainable. We have to archive this data by law. Therefore, it's sustainable. It's always going to be there. And so in a way, it could provide redundancy for anything that happens here at Crescent or a long-term repository, you know, as funding shifts, as interests shift, right? So I think there are ways in which we could work together to really have these state repositories be places where we could preserve what happens in Crescent, if that seems like it's a good route to go. You can also be a backbone for other efforts. So, you know, if Crescent is interested in different things than our citizens of Washington are mandating us to preserve, this could be a backbone for what you all are doing here. And I loved Lisa and Annette's talk yesterday, and I have the word stakeholder in here, and I'm going to come back to that. And of course, it's pretty. This is a portal snapshot of Rattlesnake Mountain area with the Quaternary faults and all the subsurface shallow wells with the geology and the LiDAR in the background. And you can really illustrate and see things very well in the portal. So yeah, I don't know if you all are a fan of the movie Contact. I am, so I hope you get this joke. Exactly. So I want to talk about stakeholder as a word, and I actually underlined it before I even heard the talk yesterday. And I realized that, I'm like, who are our stakeholders? Well, you all are our stakeholders. But then you'll see on the next slide that I'm thinking about you all as partners. I want to be partners with all y'all to make this better, right? And in the past, I think a lot of times we've thought about this as, something that we serve to people who are our stakeholders. But I think working as a partnership is going to be more powerful. And I'd really like to see that happen. So this next slide is kind of a vignette of things that maybe I thought about, ways we could interact. And I'm using as a model for this the Quaternary fault map, which is one of the layers that I'm responsible for maintaining at the survey. And just a shameless plug, it was newly released in April, so check it out. It's been updated. But I think there are many ways in which we could improve our products and host your data and have back and forth conversations that could make this a more effective resource. So for instance, I thought about, scientific questions guide what data is collected. Our fault database is currently driven by often the needs of earthquake engineers and seismic hazards characterization, but the CRESCENT community might have needs that we would force, would encourage us to change what we host. And so I would love to have the conversation stay in this room, come back and help. There's an opportunity for needs framing. So for instance, for the fault database, we needed to revise the schema to provide more and more complete fault characteristics for the people we know who are using it. And as we learn more about who wants to use this data, we can continue to revise that. So this is a living product and we want to keep revising it. But we did this with the input of community members, mainly the USGS and other state surveys. But we did talk to a few CFN members here and got some input. We'd like to keep that going. I could see you all looking at this and saying, hey, you forgot my fault over here, or this fault. That's kind of more traditional way in which we've taken input. But this is a great group for helping to gather knowledge of new studies, question certain faults that are active, and help point out errors, and kind of work together on that. I think one of the really important ones for me is data consolidation and consistency. Something I've learned through my work in communications and outreach is that when the public or researchers see the same faults in all the different resources where they're shown and links to each other, then it becomes more legit in their mind that this is really something I need to pay attention to. So, we've had USGS partnering with us on this, but we'd like to see more. If there's a Cascadia data dashboard that comes out, we want to see a consistency between what we're showing here and what happens on the data dashboard. And then also the final thing I just want to mention is that, CRESCENT could spend more time on curation and moving science forward, because we're really in the business of trying to make sure that we're preserving all this data. So there's an opportunity to kind of like split tasks, and it's like, if we're preserving the data and taking care of that, then the CRESCENT community can spend more time on like curating that data and using it to answer science questions. So I think there's a lot of opportunity for interaction and making all of our efforts a lot more efficient if we can kind of think about the relationships between what exists and what you guys are thinking about trying to build. So thanks for that. And my email is here if you see any problems with this fault map. Thank you.
All right, thanks, Megan. So last presentation before we go to the breakout sessions, I'm going to talk a little bit about some of the data products that have been produced through the Cascadia Lifelines program and several of the initiatives. So these are the different members of the Cascadia Lifelines program. If you want your logo on there, come talk to me after, I'll tell you how. But basically the Cascadia Lifelines program was born a lot out of the Oregon Resilience Plan as kind of an initiative to start looking at ways that lifeline providers can talk with one another and identify common interests and start looking at interdependencies between different hazards. And so Through this, we've developed a lot of different tools to help with hazard modeling and mapping, vulnerability infrastructure assessments, as well as outreach activities like webinars and short courses and so on. But really the goal is to help people make cost-informed decisions resulting from Cascadia subduction zone earthquakes and tsunamis. And so over time, there have been a lot of different research products that have come out of different work from several different people. So one of the probably first products that was developed through this consortium is a platform called OHELP, the Oregon Hazards Explorers for Lifelines program. At the time, we were proposing the idea of basically creating new liquefaction maps, new landslide maps, and so on. But kind of the stakeholder feedback we got is there was all this effort put in by Ian Maiden, Bill Burns, and others at Dogami to create these maps for the Oregon Resilience Plan. But in the Oregon Resilience Plan, everybody was just handed a PDF, 8.5 inch by 11 inch piece of paper, and it really wasn't usable to stakeholders to get access to the data. So that was kind of where OHELP was born, was to allow users to ingest this information, be able to visualize it, look at it in in 3D, intersect different lifeline layers and other sources of information. And so built in it is the ability to look at different hazard levels. So you can look at a magnitude 8.1, 8.4, 8.7, 9.0, and Portland Hills faults and other things have been added to it based off of more recent work that Dogami's done. One of the popular tools within it is the ability to generate a site report that gives you an idea of what potential for lateral spreading, liquefaction, landsliding you would expect from the earthquake, some basic information about the geology, to kind of give really engineers a starting point to look at their design for their different locations. Another data product we're fortunate to have Ben Lashinsky, he's one of the leads on the team for this, is called GOSEP, the Georeference Oregon Soil Engineering's Proper Database. And this exciting project, they had the fun job of digitizing about 7,000 boreholes and collecting information, dusting off all the records off the shelf and getting them into a cohesive database where the information can be put together. And they're doing some really cool work in AI and other things that I don't have time to talk about in terms of recognizing information on borehole logs. But through this effort, once we start kind of getting this information in a consistent format, they've created another platform that we would like to call the digital drill rig. And so the idea behind this tool is it looks at all the nearby borings and you select your location, and it can give you an estimate of what the soil profile would look like, as well as the uncertainty associated with that based off of the agreement and availability of data around the area. And it goes beyond just kind of showing here's what the soil layers are going to look like. It starts estimating geotechnical properties. For example, the standard penetration test, N value, or a measure of strength of the soil. You now have an estimate of what that's going to look like at your particular location if you don't have information there. So it's a valuable tool for consultants to go through before they develop their design drilling plan for a site. They can look at that estimate or use it when you don't have that option to go out and collect more additional information with it. So another tool, Joe Lewis is here. He also was the lead on developing this tool called the Geospatial Analysis for Disaster Evacuation Planning tool. So it's a GIS framework, Python scripts. He's put it all up on GitHub, so it's out there and available that you can access to start doing planning. Looking at locations where there's potentially likely to be damage, how that's going to affect the infrastructure, how you can evacuate, how you can move materials and debris associated with earthquakes, and really a great planning tool for that purpose. Another group, Shafiq, Andre Barboza, and Barbara Simpson worked on this of putting together a database of fragility curves to really get an idea of how different infrastructure performs. So they went through a whole variety of infrastructure types as well as different hazards and compiled this massive database of what are all the different fragility curves out there that are available and what sort of techniques were done to develop these. Because those of you that work with fragility curves, some of them are very rigorous based off of field validation, based off of lab testing. Others of them, somebody needed to draw something on a paper to have something to work with, right? And we have this whole wide variance. And so it goes through and kind of helps you sort through what is available and where some of those gaps are with it. And then they did a follow-on project with Nishant, who's here as well from Portland BES, of looking at the pipeline network and basically taking that information from the fragility curve database, intersecting with the hazard maps available through OHELP to start looking at probabilistically where areas that are expected to break and where are some of those challenges happening. Some other students have taken these data products and looked at, what's the probability of landslide displacements happening, exceeding certain thresholds, and how that's going to affect the transportation network, or looking at the bridge network and using the fragility curve information to see how are those bridges going to perform under these different earthquake scenarios that we have in the hazard maps and look at what that distribution of damage is going to look like at a regional scale. So Brett talked a lot about that yesterday, about the idea of taking, you know, more kind of standardized site-specific approaches and scaling up to regional scale. And that's something that's been very important to those products. Another activity that we've done in partnership, especially with CRESCENT, with CLIP, we've really found a lot of ways to integrate with CRESCENT and try to help both organizations move forward together. And one of the things that we do is run a webinar series, the CRESCENT and CLIP webinar series. This is just an example of one of the webinars last time that was given by Valerie and Andy, talking about what's happening with CRESCENT. But we're just in the process right now of scheduling next year's lineup. So I hope everybody contacts me with the opportunity to speak. It's your chance to talk about whatever you want, and everybody's excited to listen to you. It's a really great way to share some of the work that's going on, not only on the science side in our communities, but within each of the different organizations associated with that. So sign up for that. And if you're interested in being on the mailing list for it, here's a QR code that you can scan to sign up to the mailing list. We also do advertise through the CRESCENT list as well with that there. All right, so I think we have a couple minutes for questions, or do we need to jump to breakout? All right, I talked too long, sorry about that. So we are going to move into the breakout session. And at this point, let me pull up the slide here so everybody knows what they're doing. I've had a lot of practice up to this point. So if you don't like the people at your table, sorry, stay at the same table. Designate your note taker and have a good conversation, talk in pairs, talk with the table. These are the questions you want to ask. Let's get specific about what would this platform look like. This is your chance. We all complain about data. This is your chance to make it easy to find. All right, thanks.
Awesome. So we've got about 5 minutes to do report out. So is there anybody who wants to share something in particular from their table? Okay.
So one of the things that we came to right away was who is the audience for this, because that's going to really matter in terms of the data that we're going to present and all of the other questions. But regardless of that, one of the big takeaways that we were discussing in depth was that the data needs to be seamless presentations across all the boundaries so that people don't have to go to all of these different places to find the general information that they're looking for. So that would serve all audiences. And then accessibility things. It needs to be colorblind friendly. We need to make sure that the data presentation is not introducing misconceptions. So we need to roll in social scientists and educators into this effort and provide additional context along with the data that we're presenting so that it's more useful in general to a broader group of people. Because even as scientists, we don't necessarily know or understand the data that's coming from our colleagues and what it really means and how it fits in.
Give it a hit. If you could say your name.
So we talked about end of life planning. Assume that CRESCENT will die someday, and what will you do with this beautiful dashboard? And either planning for it going away and communicating clearly about that, or better yet, plan for the data to go to other kind of long-standing data sources such as the WGS portal. And then if you're doing that, think about how that data can be in the same format, how those databases can talk to each other when that does eventually happen.
Thank you. Annette?
Yeah, similar to table 3, audience came up really quickly at our table. And one of the things that we started thinking about was that maybe there are multiple audiences that would maybe be using different levels of types of data and information. So maybe like a level 0, level 1 would be those raw data products, and that might be for a particular audience where maybe some of those products and analyses and risk maps would be really useful to a different audience. So finding a way to organize by, you know, we didn't get really deep into the solutions, but different tabs or different portals or something like that, depending on sort of what type of product you're looking for so that you can gear it towards the right audience.
Any others? Okay. I'm not sure who was first. Maybe Scott and then Bill.
Okay. Thanks. Scott Bennett with USGS. About the data needs, we've talked about the same vein about thinking about our audience and different versions of databases. We imagined, you know, might be a good opportunity. Like the Washington data portal is really close to being accessible to most of the community. If someone knows how to use Google Maps, they could probably navigate the Washington data portal pretty well. but it still might be a little overwhelming. So maybe like a more layperson's version, like a 3-button version, click on earthquakes or landslides, or so even more simplified version of the data portal might kind of expand accessibility to a broader a cross section of our community. And see, for the collaborators just working with, we talked about how although these databases are excellent in their versions, but we had some comments about not all the people who should be involved in designing and compiling those databases were actually involved. And so there's a little bit of siloing that might have been going on, and not everyone that should be involved have been involved in these things, and kind of expanding the scientists involved in those efforts.
I'm just going to add from our table, we also talked about the possibility of using AI, not ChatGPT AI, but like a database specific trained AI that could help serve some of these needs and address people's very specific audience specific questions.
Bill?
So we discussed the various needs, and with the various states having great information collection, but in somewhat different formats, as well as Canada, we talked a little bit about the black hole of pain that would be required to kind of assemble these and put these in reasonably similar formats. But perhaps that's going to have to be struggled with one way or the other. But longer term, we have user needs and we have researcher needs, and we really need different databases and different derivatives that come out of the raw science data to be more practical and user friendly. And so, as Michael had referred to, and David here from Multnomah County, that we need to provide data for emergency managers and utilities and other users in a more simplified and maybe targeted manner.
Sure. Last one.
And the recurring thing we had at our table was all of the great ideas that we were having, and all the great ideas we've been hearing are all great ideas we should consider proposing seed grants for.
Yes, thanks for the reminder for that. Maybe one last one to Albert. Yeah, if we got a quick one.
Two things we talked about were discoverability. Sometimes you just don't know where this data can be, and it's very hard to find it using simple searches. So making sure we can figure out ways to improve discoverability. And then this came up a little bit with your black hole of doom, is trying to get like even metadata and database structures across like jurisdictions, whether that's county, state, like internationally. Try and be consistent and try and get everyone in the same room when we're outlining and what the databases are going to look like, because that's going to make using them across these boundaries much easier.
Thank you very much. Okay.
Hello, I'm a journalist and designer, but also a scientist at heart. And I receive a publication called Delayed Gratification, and it's a British publication, and they specialize in infographics. But I live in America reading a British publication about highly intense data. So what I'm saying is that it's possible, and that there are people out there that obsess over this the same that we obsess over it. So we have to connect ourselves, just like we're connecting in this entire room, with the people that are outside and in that discipline, because I'm eager to do that. I want to take all those numbers, I want to take all that data and make it really pretty, because I love pretty things. So I need to find more people like me, and you guys need to help me find more people like me to do that. And we're in a very creative sector of the world. The West Coast is amazing, and we like pretty things. So let's do it.
You said the publication's delayed gratification. Yeah, awesome. Cool. Thanks so much to all of you for being so engaged and for sharing out. So that's the end of this session. A couple things before the break. The first is database related. Hopefully it's okay that I'm calling you out, Mary Grace. Mary Grace Botto from NASA is here with the OPERA project. And so that's a really cool database to be aware of in terms of surface deformation. There's a poster for that downstairs so you can check out during the break. Sure, yeah.
Hi everyone, so I represent the Opera project at JPL. We'll be having a workshop related to the use of Opera products. We have the displacement products that was just recently released, April I think or May. We started producing it over North America down to Panama and including all the US territories and 250 north of the US border. So if you're interested on displacement products to integrate into your workflows and science analysis, yeah, you can attend our workshop. It's on 9/11. Unfortunately, it's the date that we chose. I don't know why, maybe, but it's yeah, September 11, and we'll send out the more information through our website. Thank you.
Thank you. Great. The second thing is that Lydia mentioned there's a CPAL database that's going into a CRESCENT format. So Loic Bachelot, who's here as the CRESCENT developer, is going to put that back up on the digital media over there. So you can check that out during the break if you're interested. And then lastly is that I'm sure there are a lot of questions that went unanswered. We don't have a whole lot of time. And so you can find the link to the question and answer form, and we can direct those to the right people if you have questions and want to connect after that. So we've got a break. It resumes at 10:45. Please feel free to get some coffee, check out the posters upstairs and downstairs, and we'll see you back here in about 10-15 minutes.
Okay, folks, I'm going to call us together for our final workshop session of the formal program here on campus. And I'm going to introduce Andrew Meigs, who's the Geosciences Education and Inclusion Pillar Lead for CRESCENT. And he'll take us through this session on workforce limitations, training needs, and geosciences opportunities. So over to you there, Andrew. Actually, I'm going to just introduce hopefully some new fellows to the room. The National Association of Geosciences Teachers has a concurrent meeting with us, and we have invited those folks into the room to join us for this discussion. So welcome, and thanks for joining. And that collaboration will continue this afternoon with our optional field trips. So those are run in conjunction with NAGT, and we're grateful for that partnership. So welcome.
Thank you, Andy. Let's see if we can get this. Hold on to my, yeah, okay. I think I'm in the wrong place here, am I? Yeah. Okay. We have three speakers. I'll be speaking, Daina, Hardisty, and Amanda will be speaking after me, and then we'll have a breakout session following the same format that we've been following all day long today. My task is to just tell you what CRESCENT is doing about the workforce of the future. When we wrote the proposal, part of the RFP, specified that our center had to address broadening participation and developing the workforce of the future, and the programs that we've built are attempting to do just exactly that, and I'll show you how hopefully we're doing that. As was described yesterday, CRESCENT has three pillars. You're part of the partnerships and application pillar, and we've been asymptotically talking about the science planning pillar throughout the meeting. And the third pillar is about education and bringing new people into the problem of earthquakes, identification, hazard, resilience, mitigation, and so forth. I want to start before I go any further, just a quick shout out, because this is really a group effort of the GEI committee. And in particular, Shannon Fasola, who is our program manager, has really made this program go from 0 to 60 in a very short period of time, which includes everything from application development to helping individual people navigate our different programs. So she really deserves a lot of credit for the successes that we've had. The other credit goes to the committee itself, which has a number of people who are very seasoned experts in geoscience education and workforce development. And it's together that we are building the GEI presence in CRESCENT. So the heart of the GEI program are these 5 different efforts, and they're organized from the top to the bottom by age almost, in so much as we're attempting to hit an audience and build the future from the high school, which is at the top of the of the list of activities here, to the bottom of the list of activities. And I'll just briefly describe each one of these, and also say something about how successful we are and things that we're doing in the future. So at the very top is the CCASE program, which is an acronym for the Cascadia Cultural and Geoscience Exchange Program, which is a high school program with two communities in coastal Washington, in Nia Bay and in La Push, Washington, which is a partnership between the University of Washington Riverways program and two tribal serving high schools in those communities. The CCASE program exists in Crescent primarily by the efforts of two graduate students at the University of Washington, Maddie Lucas and Julia Grossman. And what they have done is built a spring break exchange program in which UW students go to and work with tribal schools to combine tribal knowledge and Western science knowledge in the understanding of earthquake and other geologic hazards problems. And it serves both to bring the science that happens in UW to those schools, but also to build knowledge of, or to build relationships and knowledge between tribal partners that have how to say it, their perspective on the same issues. And it's been an interesting program because it's both been an educational experience for the UW students to learn how to build a program and to be effective partners with the tribal communities. And at the same time, it's affording the opportunity for tribal students to encounter university students and to learn about the university experience. This is a program that we hope to expand in the future. Right now, it's serving two schools, and we hope to incorporate a third school by next year. At the undergraduate student level, we have what's called a twinning program, which is a year-long research experience in which a student is partnered with two mentors, one at their home institution and one at some other institution. And the goal there is to provide a substantive research experience for undergraduates for an entire year, where they conceptualize or become incorporated into a research project, take on some part of it as their own, and see that through to fruition. One of the things that Crescent, I think, should be proud about is that all of these programs are funded. The students who participate in the twinning program receive salary during the year and summer stipend and salary to conduct the research. And at the current time, we've run this twice now. We've had about greater than 50 applications and have 11 students in the program right now. One thing that I would just mention to this crowd is that we're always seeking, and we will be seeking again starting next fall, mentors to lead research projects. And we're not solely interested in science projects. I know that there are many agency and industry people here in the room, and we're quite interested in helping to build that workforce in addition to just the basic science research apparatus that I think of as an OSU faculty member. From the just concluded, I think yesterday, was the Cores to Code Field School, which is a 3-week summer field school. It was held at Cal Poly Humboldt, in which students learn the complete workflow from the collection of raw data in the field to analysis using modeling type programs. And Shannon and Diego just came back from that. Diego Melgar, I should introduce him. He's the center leader. He has been AWOL because he's been coding with the students at Humboldt State. But the program is fun. Students spend roughly a week collecting data in the coastal marshes of in the greater Humboldt area. They spend about a week analyzing the samples that they collected from the field in the lab, and then the final part of it is using those data to understand models such as tsunami inundation in a coastal estuary. And so it's trying to provide a holistic experience in science. That program is also fully funds the students. They not only get travel support, but they receive a stipend for their participation in the program. And as you can see, it's been very well received. We had 170 applications for 10 spots. And so we will be taught one more time in 2 years. And I think the general vibe coming out of the meeting is that everybody got a lot out of it, including the instructors. So we're very happy about that program. We have a professional development grant. Oh, I know Jill and Valerie just told me I'm number one. Oh, you meant 1 minute. Oh, okay. I just took up my minute, didn't I? All right. We have a professional development fellowship. So if you are an early career person in this room, we twice a year, we have a call for applications to provide travel support, to go to a meeting, to engage in professional development. The first year, all of the people who were successful applicants to that went to the Earth Educators Rendezvous, which is an NAGT, National Association of Geosciences Teachers, biannual meeting. And then finally, we have technical short courses that are very granular and about specific methodologies related to our science pillar primarily. The one that we've run so far was about machine learning. It had a lot of response to it. We had 24 spots, and it occurred just in April, and was well received by everybody who has participated in it. So I think oh yeah, the last thing I would say is, I'll get out of this in a minute, is the only part in a workforce skill set survey, which was basically an exploration of about 1,200 job ads. The only thing that CRESCENT is not really actively doing is contributing to people's ability to drive. But otherwise, from the point of view of this survey, we are hitting in all of our programs one or more elements of what employers seek in job ads for the workforce of the future. So well, I think we inadvertently stumbled upon a set of programs that are going to meet the goal of building a future workforce. All right, so I think next up is Daina Hardisty, and Daina, excuse me, sorry, I just messed that up again. I even practiced. I have to escape out of this, don't I? Oh, okay. All right. I just messed it up, Andy. Okay.
Thank you, Andrew.
Hey, Daina.
Yeah, sounds good. Okay, my name is Daina Hardisty. I know it's spelled, looks like Dana, but it is Daina. It's a Latvian name, so the second vowel is highlighted as opposed to the first one. I brought up with me Jody Harnan. Sorry about that. Jody from NAGT. She's the secretary of this year's NAGT and last year's NAGT. And I am the host for this year's NAGT conference here in Portland. And I actually 25 years ago started hosting NAGT things. I was an NAGT host 25 years ago, but actually I was the co-host because Melinda Hudson from Portland Community College, who just retired, actually was doing the main big heavy lifting because I was 5 months pregnant and trying to navigate that whole new hosting of NAGT things. And just as a curious, surprising side note, I'm wearing the same dress I did then. So just curiosity. I saw this in my closet, went, I gotta wear this because it was NAGT 25 years ago, and I was 5 months pregnant, doing field trips and all of that. I haven't practiced this, so where are we at? How do I move forward? We're just gonna hit enter. So let's talk about, and Jody, pop in when you think I've missed something, because I'm off and on in NAGT for the past 25 years. Haven't gone to every conference, but it is a group of educators that supports diverse, inclusive inclusivity from everybody, including teachers who are not community college teachers. It could be university, it could be high school, it could be elementary, to promote high quality earth education. It was way before some of these other conferences started appearing on the stage. But we wanted to disseminate some of the research that's been going on. So we had a research talk this time. We also want to disseminate really cool, innovative teaching strategies, and to support educators that are going to be going on to the future and everything that they're doing. Make it go forward. Oh, you guys are the disciplinary, see, I knew I'd missed something. You guys are the disciplinary readers in the geosciences. So we want to support you all in everything that you do, because we are educating the new people that will be coming out and doing your jobs eventually. And that was kind of cool to see that, what Andrew put up at the last slide of the workforce. So it was cool to see that in my world, I am helping also with that driving. Well, I used to, until the laws might have changed. And I had student volunteer drivers up until this year, and maybe they have to be employed by the college. I don't know, I hope not, because student volunteer drivers means I'm supporting the driving part, having student volunteer drivers. We do have an upcoming workshop for graduate students and postdocs. So if there are any early career people who are looking into going into teaching, into an academic career, there is a workshop coming up in August. It is a virtual workshop this year, and it is an NAGT. There's, whoops, oh, go back, Daina. There is a QR code that you can use to get to this workshop page. There's also, in case you take a picture, there's also, you can type in the NAGT stuff. I've got 1 minute. Okay, keep going really quickly. You already heard about Earth Educators Rendezvous. The next one is in South Carolina in 2023. We just had a talk. We're not going because it's too hot there. So this sort of gives you a quick look on the Pacific Northwest section of NAGT. There are 117 members from 94 institutions all over the Pacific Northwest, including Alaska. And the yearly annual meetings have been since 1991, me only since 2000, I mean. And then this year's meeting was to kickstart in-person meetings again, and we didn't quite reach the goal that we wanted to, but maybe next year, which will be at Highline Community College up in Washington, in Seattle, Washington. Any questions?
Hi, everyone, and thank you for the opportunity to present today. My name is Amanda McHale with Oak Ridge Associated Universities, and the title of my talk is Enhancing Earthquake Risk Reduction Through Professional Development. So Oak Ridge Associated Universities, or ORU, was awarded a grant through FEMA, and the purpose of this grant is to support earthquake risk reduction through professional development within the seismic community. And to do this, we propose 2 grant activities. The first activity is to establish a seismic community advisory committee. And we have done this by leveraging ORU's University Consortium, which consists of over 150 institutions. And this helped us identify leaders in the seismic community who might be interested in serving on the committee. So the advisory committee consists of 7 members, reflected by the yellow star on the map. And the university logo is also on the bottom of the slide, and they represent key seismic areas. We also have an additional 17 consortium members with earthquake expertise, and this is noted with the blue bullets on the map. And then the gray states indicate that that state has at least one university participating as a member of the ORU consortium. So our advisory committee is currently providing guidance on existing and needed professional development offerings in the field. And their input is also shaping our second grant activity, which is to conduct a landscape analysis. And so the goal of this analysis is to identify professional development opportunities for students and professionals in earthquake preparedness. And to do this, we took a three-pronged approach. The first is to conduct key informant interviews, which we have done. We interviewed members of our advisory committee to kind of gather their insights on the opportunities available. We're also doing a broad web search. This is in progress. We've done the first iteration of this search to identify more of those formal professional development opportunities. And we're currently refining these lists based on committee input. And then lastly, we've created a survey to assess opportunities across relevant degree programs at universities. And so we just distributed the survey in the beginning of June to universities in our consortium, and then also with our advisory committee to share with their networks. So if you would like to share this survey with your networks, I put the QR code on the slide. So some brief preliminary findings from our analysis so far. We've identified 22 opportunities, but this number is subject to change as our analysis continues. One key challenge we've observed is a lack of interdisciplinary collaboration. So fields like seismology and emergency management seem to operate in silos. So initially, we expected earthquake preparedness to primarily fall under emergency management, but our advisory committee highlighted several other relevant fields such as civil engineering and geography. We've also found that opportunities in this field are often informal, relying on more of those personal connections rather than having systematic programs in place. And then there's also a lack of awareness about the field itself, and this makes it challenging to attract students and professionals to this field. So these findings are shaping our understanding of the landscape, but they'll also inform recommendations to FEMA moving forward. The next two slides are some of the types of opportunities we're finding, just for your reference if you wanted to look at these slides later. This one is from CREW. And this one is from the Natural Hazard Center on Shake Alert coming up in July. And thanks for listening. Our contact information is on the slide. If you have any questions for me or Jennifer, feel free to send us an email. And then I also included the university survey QR code again. Thanks again.
Okay, thank you, Amanda. Now we're going to move to our breakout session, which I think is going to follow exactly the same format that we have already been following all morning. So first of all, if you would consolidate so that your tables have a critical mass.
Hi, everyone, and thank you for the opportunity to present.
You're welcome. The following instructions: pair or small group discussion of the questions at the individual table. So pair share means turn to your neighbor and explore these questions. Let's find a note taker and a timekeeper for each table, but we'll, I think, give you a 5-minute warning before this is over. And then we'll do a group share at the end of this. So please reconfigure yourself so you have someone that you can work with and get to work. Okay. As usual, you all set to work very productively, which is a fun thing to just hear from the background. What we're going to do a little bit differently in this share is to run through the individual questions and try to give roughly equal time to what your tables may have responded to those questions. So the first thing is we're looking for volunteers to make any comments about what your table discussed for question 1. What are the skills and workforce gaps of your discipline? And in particular, if NAGT people have observations from what they heard, we would be quite happy to hear your voice. And Valerie's going to run around as she has been doing. She's training for a marathon. This is ideal. All right, Diego.
So I don't think this one fits necessarily into 1 or 2 or 3, but we spent basically the entire time discussing what are we doing in the education and pedagogy space with AI and ChatGPT, and how we handle how that's a tool that people need to know, but it's also a tool that makes essentially the modern Western educational model no longer work. How we build assignments, how we evaluate folks for those assignments. Basically, we have no idea what should be our response as educators to this or proper revolution that is happening. And we came up with no solutions, but that's essentially all we talked about for the entire time.
The other possibility is open-ended, as Diego has just shown us.
We brainstormed a laundry list of gaps. Science communication training and opportunities was one thing. Geoscience ethics in general, which helps AI, falls right well into that, which we also spent time discussing that. GPS, but also cultural competence and knowledge skills, as well as critical thinking.
Maybe one more for this topic.
At our table, we had a whole thing on communication. And one of the things, there are 2 sort of forms of communication, interdisciplinary communication, because each group speaks a different language. I thought that was a really good observation, and that actually makes it hard to communicate between different groups. The other thing is when you're coming into the workforce area, sometimes you don't know how to get to where you want to get to. You know what your degree is, you know what your background is, but you don't know how to get to do what you want to do. You may not have the contacts. And so I think that's a big, huge one. I know when I was young and starting in the workforce, that was a huge one for me. I did not know how to get to where I wanted to get to. It was really, really difficult. And it felt like it took way too many years to get there.
Okay, I've been volunteered to share some of the excellent ideas from my group, so I'm going to do my best to represent them. But one of the things that really quickly came up in our conversation is that we couldn't really talk about professional development without really quickly bringing in the idea of equity and inclusion and thinking about on-ramps for professional development and joining the professional workforce following non-traditional or maybe more circuitous life paths. So creating more of those on-ramps. And specifically one sort of skill gap that we talked about that is maybe a less tangible skill was just the confidence to try something new, and how do you help instill that confidence in your developing workforce to just try something new and learn a new skill.
The first one, Andrew.
Does anybody, I did see Scott Bennett's hand up a moment ago.
Yes, Scott Bennett, USGS Portland. One of the gaps we talked about in skills and workforce was the general decline in the focus of field-based science, because so much of geology is inherently a field-based observation practice. The workforce we see coming up these days is slowly getting less and less experience in that, either due to changing curriculums in the university level or other factors. But that's a workforce gap that we have discussed in our group.
Okay. Hey, Beth Reddy, Colorado School of Mines. So we talked a lot about the need for interdisciplinary training, geology skills, some of the good that getting outside does. I think a lot about ethics and values in for especially the engineers I teach, but also I wanted to like super emphasize teachers are doing so much already often. So one of the things that came up in our conversations um, was about other kinds of opportunities, like maybe ongoing education, things that could happen in extra or additional curricular activities, um, simply because we're really, really aware that um, the level of thinking that teachers are already putting into their course design and development is so significant at this point already.
Maybe.
Right behind you, Valerie.
Sure, yeah. One more.
Thanks, Arlene. I'm Mike Kortenhoff, Oregon DEQ. We talked about training and credentialing in emergency response work, or emergency management, actually, not response work, as an additional element to this. You know, to my ear anyway, I love the talk about training scientists, but both the emergency management world has training, but I don't know how it's getting to the young workforce. People get into it maybe out of the military or other ways in mid-career, but something there seems helpful. And in particular, regarding the future mitigation work in the Portland Harbor area, you know, I'm hearing questions from the community about what kind of jobs will that bring to community members. That might be construction jobs too. And so short courses perhaps for people who are in trade path training so that they understand the value of this work and how it fits and might help supplement a workforce for the construction work that's needed and starting any year now. It will be huge.
Do we ever other thoughts about training and opportunities in education
For
that
the
people
second
would like to
question?
share? Yes.
Okay.
I thought I'd take this opportunity to ask, because this is something I'm really interested as a education researcher in exploring what are the specific pathways and kinds of education, much like the research that was just introduced, that students need to go into disaster risk reduction, disaster risk mitigation, not just satisfying the like checking the boxes, but to do it well, and to do it well at this particular moment in our history. So if anyone is interested in exploring that as a research opportunity or being involved, I would love to talk more. My name's Beth. Hi. Okay.
Anything else on the second question?
Or anything that your table wants to offer really is what we're looking for here. We could, oh,
Howdy, y'all. We were saying one thing particularly geoscience based is some schools are really good at this and some are really bad. Motivate your students to get their license. It only opens career paths. It doesn't close or narrow it. And then also to add more applicable what they will be doing after, not just the core courses, and that could be done through seminar series or even following someone along at a day of work.
Ashley and then Bridget.
Hi, I'm Ashley, Portland State University. I'm going to do my best here, so let me know if I forget something. We talked about a couple of things, and we were pretty broad. First, the interdisciplinary nature of geologic hazard analysis. So that was something that came up as a point of interest, that we really aren't trained in that in college, in the college setting, that it's something that we experience later, you know, as we're employed. And so it would be really cool to see some kind of cross-disciplinary collaborations in the university setting. We talked about skill and workforce gaps in local communities, specifically smaller communities where it's really hard to get these resources to. And we talked about trying to figure out like what solutions would be. Some specific examples were in smaller communities, lack of GIS experience when we need to create heat maps was something that we were talking about, or, you know, a landslide susceptibility evaluation, but having no one who is able to do that locally. And so how do you train and get to these smaller communities and help them contribute to their own problem solving? Rather than hiring out. And then we talked about problems at the two-year college and university setting with funding. I know it's shocking, but maybe not having enough professors who can teach all of the courses that we'd like to teach, that and the skills that we in the room have been talking about in the last 2 days. And you know, our salaries are low. Also shocking, I know. And so it's hard to recruit and retain people with these skill sets when you're at a community college and you want to work with an engineer or keep engineers at the community college setting. You know, the salaries are just very low relative to other industries and to the training that those individuals have. We talked about resources pretty briefly. We talked about a lot of searchability problems. So there are lots of great resources through EarthScope. I know EarthScope's here, and Open Topography that can maybe answer, you know, fill the gap a little bit. There are training opportunities and virtual workshops. And so trying to make those more visible, that might be something that we can do as CRESCENT. I know SC4D has been pretty good at advertising those things, those types of resources, but maybe we could do better in making sure that our community is also seeing those opportunities. And we also talked about just a general geology perception problem. And, you know, we're talking about the workforce, but let's talk about like the people coming through and entering the workforce eventually. You know, geoscience isn't taught on par with other sciences at K through 12 education. And so we have a little bit of a perception problem as well. And I proposed a Got Milk campaign, but got Earth. So anyway.
Bridget.
Hey there, Bridget Good. I am with OEM. So we are a table mostly of emergency management professionals. So a lot of ours came down to funding, talking about maybe collaborations across some of these fields. So from academia to scientific organizations and over to maybe get us some interns. But we also talked about how difficult that is because we are so under-resourced already, and there's a heavy lift to get an internship program started. And one final thing that kind of came up is, you know, we keep talking about these different languages that we're speaking, and I think it would be really nice if we could come up with some way to get emergency managers to be able to take some of those college level geo courses so we have a clue what's going on and we can maybe better disseminate the research that you guys are putting out, right? So we have a better understanding of what those publications say. So maybe some cross training within our fields would be really great.
I'm Carrie Garrison-Laney. I'm with Washington Sea Grant, and I'm a member of the Cascadia Coastlines and People Hazards Research Hub, or Cascadia COPES Hub for short. And it's similar to CRESCENT in some ways and different in other ways. But on your comment about, you know, translating some research for emergency managers, that's one thing I've heard many times from emergency management people in Washington is all this great research you're doing, please translate it and, you know, make one-pagers or slides or things that we can use so that when people ask us, hey, what's the CRESCENT doing? You know, they can talk about it in a way where they sound informed because they don't want all this cool stuff going on in their backyard and not being able to communicate it to people. So that's something we need to make sure we're doing as well, is providing all of those explainers.
Thanks for that. Any others?
Oh, over here.
Lori?
Well, being the rebels we are, we didn't exactly follow the questions. And we actually talked a lot about structural impediments to getting people into the field. I know at my institution and at many, there are very few students who come into the earth sciences as freshmen. And by the time our senior classes are like 5 times the size as our freshmen, or maybe even larger, because they've been forced to take a GE class in earth science. And wow, it's the most exciting class they've taken. So in California, we have severe structural impediments in that the University of California system really doesn't want to accept a high school or science class as acceptable for college admission. And even though that officially kind of changed a little bit, maybe a decade or so ago, it really hasn't. And what we see in high school earth sciences, not everywhere, is that that's the dum-dum class. That's the class that you take if you can't face physics. It's the acceptable physical science. Even lower down, it used to be a requirement for multiple subjects teachers to take a geology class. We had a class specifically that was geared for teachers. It must be 20 years ago that that was canceled. Now all multiple subject students have to do is satisfy their GE requirements. So we have a real structural problem in that people who might be interested in our field don't get exposed to it till much later. And we see a lot of people coming through from different avenues. I don't really know how to solve that, but recognizing that is one of the issues. Anyone else at our table want to add to that? Any rate.
Okay. Where you had to run really far to come over to get to me. Hi, I'm Yume Wong. I wanted to follow up on what my neighbor, Mike Kortenhoff, said. He mentioned that the Portland Harbor is a Superfund site and it's going to be $1 billion a cleanup that's going to start in a few years and go on for a really long time. And there's a lot of opportunity, talking with our NAGT rep here, to create programs or class certificate certifications, I guess, or short courses for the trades folks in construction who are working in these areas so that they can have an appreciation for environmental cleanup. So, why don't you want to have a bunch of sediment in the water when you do construction and so forth? And although it's already a Superfund site, I do want to mention that there's the high risk potential for it to be a super fun site with all the fuel tanks that could get shaken and damaged and have fuel released into the land and river. Thanks.
All right, I think we have time maybe for one last comment. Otherwise, thank you very much for,
Sure.
Yep, okay. Good.
I'm back with more hope. I grew up Hawaiian, and the word for land is Aina, and that's the first thing we learned. So I'm hearing there's a disconnect between the structure of our high schools and our colleges. And I was 6 years old learning who Pele, the fire goddess, is and what lava does and why we respect that. And in the geology and all the research I've done, also I'm a student of Daina, a forever student of Daina. Learning to respect the land, everything else will follow. But
thank you. Okay, be sure to, are you?
The last thing I wanted to say is I hear the word language happening, and please raise your hand if you've ever been to a country where you don't speak the language. Put your hand down. It was awkward, wasn't it? It was weird. But I think we all have key experiences from those countries that were the most fun we've ever had, and it took getting out there. So just like I don't know the language of GIS, I need to put myself in that space and kind of like work it out, but have fun with it. Because everybody here said good morning at 8 a.m. and that's inviting. So if we can invite people that don't know us in, and we can teach them what we know, I think we're going to go to a pretty good spot.
Thank you. Please be sure to send your notes to Cascadia Quakes, and thank you for your participation. And Andy's going to take us home, I believe.
That's right. Thank you, Andrew. So yeah, thank you all for that discussion, but for all of those over the last 2 days, you can go home and sit in silence on meditative retreat now. But yeah, just to know that for us, really the work begins now in like kind of processing all that rich data. And so your notes are what are going to be our archive of that. So please make sure if you've got any outstanding documents that you're working on that we just get them through to the Cascadia Quakes email. And then yeah, also acknowledging that the work here is it's a continuation of 2024 in our workshop last year, but it's still just scratching the surface in terms of what we need to do. And so I'm kind of going to leave us with a few and what next in the classic experiential learning cycle. And so we do have, yeah, we've already set the dates for next year for this event, June 25, 26. Put that in your diary, most likely here at Portland, but we'll announce that location closer to the time. Another CRESCENT opportunity is our annual meeting, October 28, 29 this year. Registration is open for that now. QR code on the slide there, and that closes in a couple of weeks. That will be up at UW in Seattle. Partner opportunity and is the 13th National Conference on Earthquake Engineering. So thanks, Heidi, for bringing that one along. There's the flyer on the back table in the registration for that. But yeah, QR code for that event there too. And then because we've just been talking about education, I'm leaving you with 2 homework assignments. This is the take-home exam. We have a survey that will go out to you via email, and we will be bombarding your inboxes because we know that some of you need reminders. So the due date will be on the email that comes out. If you're an overachiever, you can get started on that right now with the QR code. Thank you to Michael Coe, CRESCENT's evaluator, for putting that together for us. But again, that will be a good source of data for us building the next workshop and getting a feedback on what you liked about this one. I'm going to introduce Diego, our center director, to have a few minutes just after this, but this is the in-person exam. I'm going to give us a 5-minute exercise just to kind of take stock of what you've done in the last couple of days. And on your tables, there are index cards. I invite you on one side of the index card to reflect on your key workshop learning. What was the aha for you? And then on the other side is your commitment to action, a potential collaboration that you're going to follow up on. And so I'm going to give Jill one last chime opportunity. She'll chime that after 5 minutes, and then I'll hand over to Diego for a closing remark.
You can leave the cards on the table, and then we'll collect them. One last little bit before we're released into the weekend. My name is Diego Melgar. I'm the center director. For those of you that haven't met me, my apologies about missing the meeting yesterday. We were wrapping up the last week of our Course Dakota Summer Field School down in Arcata, California. The whole ethos of this meeting is to do away with the concept of the ivory tower that Western science thinks that scientists are perched atop of. And so the point of today has always been to try to intersect the research and science that CRESCENT is funded to do with all of you that have to put that science to work. That philosophy for the center is Valerie's brainchild from proposal inception through to today. And making that happen requires building a complex network like the one here. The connections between you are tendrils, and there are many of them. And figuring out those connections and managing them is Andy's job. And he's taking that on in stride in the last year and a half. So please join me in thanking them for that and for their efforts. It's really been a labor of love for both of them. And so as a small token of our appreciation, we have something for them. In the Quileute tribes legends and of other peoples of coastal Washington, there's the legend of Thunderbird and Whale, familiar to many of you. And it is oftentimes thought that earthquakes and tsunamis are due to the epic struggle between Thunderbird and Whale. So we have for Valerie and Andy a couple of prints from Native American artists from the Northwest Tribal Art Gallery in Seattle that they can take home and have adorn their walls and hopefully remind them that we are forever grateful for their leadership. Thank you.
Thank you so much. Okay, just the eternal reminder to the biggest part of being a community is staying in touch. So please use these resources to kind of keep the conversation going when we're not in these meetings. And yeah, those are again on your handout and anything that we send out to you. So yeah, please use those.